All right, let's start with a net force diagram. So here's your situation. You have an elevator accelerating downward. And the first part of a good diagram that'll really explain this situation is to draw a sketch. My sketch is very simple. It's just two guys in an elevator. There they are. The second thing we need to do is we need to identify the system. I did that by circling the part that matters, which is the elevator car. Step 3 is to list any forces that are on the system. And this red circle really helps me to do that. See, inside the circle we have the system. Outside the circle we have the environment. And anytime the environment and the system interact with each other, there's going to be a force. In other words, anytime something crosses that red line. So right here, I have the cable crosses the red line. And so I know the cable must be applying a force. And so immediately I drew that there must be a force upward from the cable. The second thing I realize is that there are usually two kinds of invisible forces on any object. The first is a force downward from gravity, and the second could be a force of friction. In this case, friction doesn't really matter, and we're going to ignore it. But what does matter is gravity, and so I went ahead and drew a downward force of gravity. Step 4, I'm going to indicate the acceleration and the net force. Now, in this problem, it tells us that the elevator is accelerating downward. Not all problems are that generous, but this example is especially easy. And so I can go ahead and label that the acceleration is downward. If the acceleration is down, that means there has to be a force downward also, a net force. Once I know those two things, I can go ahead and draw my free body diagram. Basically, I'm just going to take these two forces and put them right here. The dot represents the elevator. There's an upward force from the cable and a downward force from gravity. The only other thing I need to make sure of is that this diagram shows a net downward force. And it does. That's why the gravity arrow is bigger than the arrow from the cable, because the force of gravity must be larger in this case. Okay, once you've got your free body diagram and your whole net force diagram together, there's one more really important thing. And if you want to get any physics problem correct, this is usually the most important step. And that is to use your free body diagram to draw or to create an equation. So in this case, our free body diagram showed that there was a force from the cable and also a force from gravity. Now, how do we turn that diagram into an equation? Well, it's pretty simple, actually. In this case, we're going to write a net force equation because we know there's a net force on the object. So we start by simply writing F net for net force. And then we're going to write out the forces that determine the net force. In this case, we have the force of gravity down and the force of the cable up. The only thing left to do is decide what sign to put between these. In this case, I've decided I'm going to make gravity the positive direction because it's bigger, and I'm going to make the cable the negative direction because it's smaller, but I could do it however I want. So gravity stays positive and the cable becomes negative. And that's it. That's your equation. That's points on the AP test, and it's probably the road to a correct problem.